Hello and welcome to Mechanics 1 problem solving. I'm going to take you through one of the questions where students normally find challenges, and these are questions which involve rings and beads which have been passed through either strings or rods. The rods may be rough or they may be smooth. So welcome to Mechanics 1, where we look at this particular concept. Hello and welcome. In this video, I'm going to teach you a very important concept, and it involves rings and beads, especially rings which are passed through rods in Mechanics 1. And the best way to look at that is to look at a past paper question. Let's have a look at this question here. A small ring of mass 0.03 kilograms is threaded on a rough vertical rod. At this point, I want to mention that they've mentioned that the rod is rough so that you can know there is friction force which is acting between the rod and the ring. A light inextensible string is attached to the ring and is pulled upwards at an angle of 15 degrees to the horizontal. I'm going to refer to that one in a moment. The tension in the string is 2.5 newtons. The ring is in limiting equilibrium. They tell you it is in limiting equilibrium so that when it comes to calculating friction force, you can use the equation friction force is equals to mu r is equals to coefficient of friction times the normal component of the contact force. The other concept you should realize here is that they've told you it is in equilibrium so that you can know that the resultant force acting on the ring is zero. Very important. So you're told that it is in limiting equilibrium, and on the point of sliding up the rod. The reason why they've told you it is on the point of sliding up the rod is so that you can realize that friction force is down the rod. If you're told that the object is at the point of sliding maybe to the right, it's a way of telling you friction force is to the left. This time, the ring is at the point of sliding up the rod, so you should know that friction force is down the rod. And then what else are we given? We are asked to find the coefficient of friction between the ring and the rod. Very important. So let's have a look at this. This force is inclined at an angle of 15 degrees to the horizontal. Remember, when a force is given and it is not in any of the two standard directions, what do I mean by standard directions? Standard directions are horizontal and vertical. Those are standard directions. The other standard directions come in when you're looking at an object on an inclined plane. So if a force is parallel to the incline or perpendicular to the incline, those directions are standard directions. And when a force is in a standard direction, you don't bother resolving it. But if it is not, then you have to resolve it so that its components are in those two standard directions. What do I mean by that? Let's have a look at this force here, 2.5 newtons at an angle of 15 degrees to the horizontal. We are supposed to resolve it so that one of its components will be horizontal to the right, the other one will be vertically upwards. And remember, you always resolve a force twice, all the time. So let's see how I've been able to resolve these two forces. So you go to this diagram here, and the 2.5 Newton force is here. You see that? So I get its horizontal component, which is 2.5 cos 15 degrees, and that is obviously this value. Then I resolve it in a direction which is perpendicular to this component, and this one takes a sign. And that one has a value of, I think, yes, I'm supposed to write down that value here. I'll write down it in a moment. The other force is this. The ring makes contact with the rod at this side. And therefore, I'm supposed to get the normal component of the contact force. You know, there is a contact force between the ring and the rod. And that contact force has two components. One of them is the frictional component, the other one is the normal component. So we can get the normal component of the contact force. It must be in this direction because the ring makes contact with the rod on this side. The frictional component, we have already agreed that it is vertically downwards. Why is it vertically downwards? It is because the ring is just about to slide up the incline. Remember, we are given this term so that we can know certain things about the situation that we are describing. Of course, the ring has a mass of 0.03 kilograms. We convert that into weight by multiplying it by G. So once we've made sure that all the forces are perpendicular to each other, for example, this force, this one, and this one, they all make a cross. They all make a cross. We look at the state of the system. We are told that the system is in equilibrium. And that means that at this moment, we can equate those forces which are in opposite directions. For example, we can say that this force here, 2.415 newtons, is equals to R. You know, I've already worked out 2.5 cos 15 to get 2.415 newtons, and that is why I'm saying 2.415 newtons is equals to R. The other forces which are equal will be the sum of downward forces, which is friction force, plus 0.3 should be equal to the upward force, which is 2.5 sine 15 degrees. And with that, at this point, I'm able to get R, and at this point, I'm able to get friction force. Remember, the equation I want to use here is friction force is equals to mu R. That is why I should know the direction in which my calculations is moving. By the way, when you do many examples, you solve many of these past paper questions, you get to know the direction in which a given calculation should be moving. It's not just a matter of writing down figures on the question paper and hoping to get marks. No, you should know the direction in which it is moving. For example, I've already determined that I need to get a coefficient of friction using the equation friction force is equals to mu R. And that is why I must struggle to find out where is the value of R, where is friction, and how do I get it so that I can eventually combine them. And this is how I go ahead and combine the two. So this value, I already have it. It's 1.930 newtons. That is 2.5 sine 15 gives me this value. And that directly tells me that the value of R is this much, 2.415 newtons. And then I can get friction force by equating the sum of downward forces, which is friction force plus the weight of the ring, is equals to the upward component, the vertical component of the tension in the string. And through that, I can get friction force as 1.630 newtons. Then the next step is just to use mu is equals to friction force divided by normal component, and I get my value of the coefficient of friction as 0.675. So questions that involve rings, beads, and rods or strings, whether the rods are smooth or rough, are very common in Mechanics 1. And when you go to the video description, you'll find that I've given you the questions, or rather, I have given you some reference to past papers, the specific questions where you can get this question being examined, rings and rods. The other thing I've given you in the video description is that I've given you a link to one of my courses at Udemy called Mechanics 1. In this course, I've dealt with these concepts in details. So if you want to read or to learn more about rings and beads and rods, whether they are smooth or rough, just go to that particular course. I've given you several videos which are free so that they can help you decide whether the course is worth purchasing or not. Just go through the free videos and you will see that they can be able to help you, even if you're not going to purchase the course, but they're going to help you in the long run. Otherwise, I'll see you in the next video where I'll talk about the next question, which is question number 2. See you in the next video.